All right, Kens, this is 2-8. This is the last half. I said, these are the last bit of notes that I'm going to give you all year. And the kids are like, not funny, right? All year till Christmas break, right? Because Monday we start review. And I don't have your review packet done, but I will have it by Monday. So hopefully, yeah. All right, example 4 is where we're at. This equation right here is something called the difference quotient. We use that in calculus when we are finding derivatives. So this is the equation for a derivative, except there's a little bit more to it. It involves a limit. As x approaches h, goes in front of it, all that good stuff. You don't need that, so don't write that down. But this has to do with a limit, so if you're wondering, like, what the heck does that even mean? This is what you use to find a limit and find a derivative, okay? All right, what we're wanting to do is we're doing this whole thing for this function, okay? And it's going to be kind of disgusting. There are kind of like 3 pieces to this, okay? We've got this guy minus this guy and then all over h, all right? So I'm just going to start with the f of x plus h. If that said, like, for instance, like f of 3, that means plug 3 in for x there and there, right? Okay? But the fact that it says f of x plus h just means you take x plus h and you plug x plus h in there and there, right? Okay? So that's going to be kind of a mess. I'm just going to start 2x squared minus 3x. I'm just putting x plus h in place of those x's. Got it? Like I would if it was a number, right, that I was plugging in. Okay? Now this is the disgusting part, because this thing I have to FOIL. So x plus h times x plus h. All right. Okay. X times x is x squared. X times h, what should we call that? Like xh, sure. And then I've got another middle xh, so plus another xh, plus h squared, right? So x squared plus 2xh plus h squared. But then I got to take everything by times 2 because there's this 2 out in front, right? Okay, so now I've got 2x squared plus 2xh plus h squared. Is it not 4? Oh, wrong. Yes. My brain just shut off after the first distribute. There we go. 2x squared plus 4xh plus 2h squared. Blah, 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 blah. Okay, now I got to do this part right here. Distribute your 3 through. So minus 3x minus 3h. Right? If I distribute the negative 3 through. And that's that whole thing right there. This is f of x plus h. What? FOIL this guy? Because he doesn't have a square on the end of him. I just am distributing the negative 3 through. That's it. Okay? All right, so that's the most disgusting part. That is this part right here. Now I have to do minus f of x. Well, what is f of x? Just this, right? This is f of x. So minus 2x squared minus 3x. Now we have to be careful, because if we're subtracting f of x, now I have to distribute my negative through, right? So that will end up being minus 2x squared plus 3x, okay? And some nice things are going to happen because we're going to have stuff cancel. All of that is over top of h on the bottom. Okay, and we'll see what this happens. What? Just the letter h. Yep. Okay, so combining like terms, 2x squared minus 2x squared, that cancels. Boom, boom, got it. Okay, my 3x, negative 3x plus 3x, boom, boom, that cancels. So all I have left here is 4xh plus 2h squared minus 3h all over h. Yeah, so this guy up top here is 3 pieces, and I can pull an h out front. So if I do that, I have h, and that will be like 4x plus 2h minus 3, if I pull an h out of each piece. Okay, and then I have an h on the bottom. So now I can cancel those 2 h's. And final answer, out of all of that ugly junk business, is 4x plus 2h minus 3. Whoop. That is a derivative. That's the derivative of that guy. Okay? Yeah. So, not very pleasant, but, whatever. It's fine. I don't think I gave you very many of those. So anyway. Okay, last concept is composition, and that looks like Fogg and Goff, right? Okay, so that is different than this. What does this mean? This means multiply, right? This means composition. Okay, this guy means you're taking g of x and you're plugging it into f of x. Okay, here's why a composition exists, all right? And you don't have to write this down if you don't want to, but here's my pet peeve. I used to work at Herberger's when I was in college, and we would have customers that come in and there would be like a sale going on for, let's say, 50% off. Okay, and then they would come in with a coupon for 25% off, right?
75% off.
Yeah, and they would be like, you add those together. So if I'm buying something for $100 and it's 75% off, it should now be $25. And they would get pissed when it would actually be like closer to $30 instead. And I'm like, that's not how that works, right? So the first thing that you do is if you're buying something for $100 and you take 50% off of that, right? Now that $100 drops down to $50, right? Because 50% off of $100 gives you $50. But now I'm taking 25% off of the 50, right? Okay, I'm composing them. So 25% off of 50 is like, I don't know, $12.50. Whoa, where did I go? 25% off of 50 is $12.50 off. So that means the item is now $37.50 and not $25 like they thought, right? Because you don't add the percentages together, you stick one of them inside of the other, right? After I figure out the 50% off, I then do the 25% multiplied by that, right? It's not adding the two together, okay? And then I would go to them and I would say, like, okay, does it make sense that if something's 50% off and I have a 50% off coupon, does that mean it's free? According to their logic, that's what they're thinking, right? But that's not how that works, right? It's 50% off and then 50% off of that number, right? You're not adding the percentages together. So that's what a composition is. You're taking something and then you're applying another thing to it, okay? So this guy right here, we have two functions. We have f of x and we have g of x, okay? And this one is saying f composed of g of 2, right? That's open circle. Sometimes people will write it with a parentheses instead, and they'll write it like this. That means the same thing, okay? So f composed of g of 2 or g of 2 inside of f of 2, that means the same thing if they write it with parentheses. So I start from the inside, yep, I put 2 in for g first, okay? And if I put 2 in there, 4 over 2 minus 1, 2 minus 1 is 1, so 4 over 1 is 4. So this guy, g of 2, comes out to be 4, right? Now I am finding f of 4. It's like I've applied the coupon, or I've applied the sale. The sale gives me $4. Now I'm taking that $4 and I'm plugging it into the coupon. And if I plug 4 in here, I end up getting like, what, 8 minus 1, 7? Final answer is 7, right? Yes. Yep. So I plug 2 in first to my inside function. I'm like working from the inside out, right? 2 into my first function, then I plug that into the outside function, okay? All right, same thing with B. Now I'm plugging 3 in, but where do you plug 3 in first? F, and for x on F, right? I've got to find f of 3 first, right? Okay, so 2 times negative 3 minus 1 is negative 7. Negative 6 minus 1, negative 7. Okay, now I want to find g of negative 7. Now I plug negative 7 in for g. Okay, so I've got 4 over negative 7 minus 1, which is 4 over negative 8, which is negative 1/2. That's my final answer. Okay, so I'm applying the sale and then applying the coupon, right? You apply from the inside out. Got it? Yep. Okay. Now, here's the problem. What if they don't give me a number to put in here? What if they just leave it as x? Then I take my inside function. Which one's the inside function? G. I take the whole g and I shove the whole g into f, right? So f was the square root of x. Now this is not going to be x anymore, and I'm taking g and I'm shoving it into that spot, right? So he will be the square root of 4x plus 2. I'm taking that 4x plus 2 and shoving it in for x, okay? Now they want me to determine the domain, right? Okay, we said 2 things screw up domain. They are a negative inside of a square root and dividing by 0. Which one do I have to worry about? Negative inside of a square root, right? Okay, so I have to figure out what will make this negative, right? First things first, I set that thing equal to 0. If I set 4x plus 2 equal to 0, right, and I subtract 2, 4x equals negative 2, and I divide by 4, it will be negative 1/2, right? Okay, so negative 1/2 is my split. I'm going to go over here to like negative 1, and I'm going to go over here to 0. Am I allowed to plug in negative 1 right here? If I plug negative 1, 4 times negative 1 is negative 4, plus 2 is negative 2. That's not going to work, right? So this doesn't work. If I plug 0 in, does it work? Yeah, that will work, right? So my domain is going from negative 1/2 to infinity, because those numbers will work. Does negative 1/2 need a bracket or a paren? Can you touch negative 1/2 exactly? If I plug in negative 1/2, it will end up being 0. Can you take the square root of 0? Yes, so he's a bracket. Okay, good, good. All right, now they're wanting me to do the opposite. They want g composed of f, so now my inside function is how much? I don't know what just happened. Beep. Now my inside function is f, right? So I'm taking this f and I'm shoving it into g right here. So 4, instead of 4x, it's 4 square root of x plus 2. Okay, now, as far as domain goes, I have to worry about this guy being a negative, right? So x can't be a negative, so x has to be what? Greater than 0. So I could say 0 to infinity, or you could say x has to be greater than 0. Can it be equal to 0? Yes, so that or this. Either one of those will work, right? Something of that nature. Okay? Good? Did I leave a dirty Kleenex on your table? Or is that yours? Okay, as long as it's not mine. Oh, that's fine if it's yours, but as long as it's not mine. All right, okay. Last thing. Let f be this and g be this, and show that g composed of f of x and f composed of g of x are not the same. Okay, and they will not be the same. So let's do over here. I'm going to split this into 2. I'm going to go g composed of f of x, and then I'm going to go f composed of g of x. Okay? All right, let's deal with this guy first. So over on the left side, my inside function is f of x. This guy is going into here and into there, right? There's 2 x's. Okay? All right, so what will this look like? 2. I'm going to do big parentheses. 4x plus 1 squared plus 5, and then big parentheses again, 4x plus 1. Okay, I'm not going to FOIL this out. I'm just going to leave it the way it is, because we're just having to compare, right? Okay, if I shove g into f instead, if I do that, okay, now this whole thing is going into there, right? So 4 is on the outside. 2x squared plus 5x plus 1. Are those two things the same? Nah. Those two things are not the same. If you shove one into the other and one into the other, they will not necessarily be the same. Okay? So you have to pay attention to which one goes which place, right? Okay. All right. Here's my favorite. These are my favorite. F composed of g. All right. They say f composed of g of x is this whole big thing. They want me to tell what f of x is, and they want me to tell what g of x is. Okay, so first of all, basically I'm picking it apart. I'm like pulling it out, right? Okay, which one is the inside function, by the way? G, right? It has to be g because g is on the inside. Okay, which function am I like sticking inside? Yeah, but what part of this is getting sticked inside? Yeah, x squared minus 5. That's like what's going inside of the parentheses, right? So I can call g that, but what would x be then? Or f be then? It'll be this guy to the third, right? But that'll just be x to the third, right? Minus 4x plus 3, right? Like if I do that, would that work? Like this guy would go in there and this guy would go in there, right? Yeah. Yeah. That works. So they're just wanting you to like recognize the pieces and pull it apart, right? Okay. All right, that is all.
Can you go over
The table on 40. Have I scanned this yet? I'm going to keep recording for Mackenzie in case she has a question with this. But I'm going to see if I can, I don't know if I can scan and still stay recording. I think I can. Can I scan somebody's?
Yeah. Well,
On 40? That's fine. 40? Is that what you're asking for? Yeah, okay. Okay, this is not that bad. I like this question. And it's easier than you think it is. PDF, cancel. All right, all the way down to the bottom. 40. Okay, it says, use exercise 38 to complete the table. So we're looking at this little table right here, and we're completing this table right here. Okay, so we're starting with -2. Yeah? And we want to take f, basically f of -2 plus g of -2. That's what this first column says. Okay, but looking at 38, what is f of -2? -4, right? So I'm taking -4 and I'm adding g of -2, which is 2. Okay, so what's -4 plus 2? -2 goes there. Okay, shall we do a minus? Okay, minus is f of -2, which what would we say was -4, right? Minus g of -2 was 2, so that will be -6. Yeah. Now we're doing f of -2, which is -4, times g of -2, which is 2. You see where I'm getting these numbers from? Just from the table up here. So times, that'll be -8. And this one, f of -2 is -4 over g of -2, which is 2. So that will be -2. Some of these might end up being disgusting fractions and stuff or whatever, and that's fine. Okay? You just leave them as a discussion. You might end up with some, I'm going to guess you're going to end up with some of them that are undefined if you're dividing by 0. But that's how you fill that table in. Good, good? Anything else? I'll just let you be then. Okay, all right. I'm going to stop recording. Bye, Kens.